Hello, I'm Yifan.
Hello, I'm Humvo, and today we're gonna do the demo for Lab 2, the digital to analog converter along with a microcontroller. So, first of all, I'm gonna talk about the setup. We have our Raspberry Pi, we have our DAC, we have our buttons used to trigger the function, and we analyze the waveform by the analog discovery 2. So first of all, I'm gonna demo the first um, wave, the square one. So when I compile the function, when I compile and it do nothing, like you said, until I hit the button. Now it's gonna start asking me the maximum voltage, which I'm gonna choose 215. Frequency, I'll choose 10 as square wave. And now it's gonna start generating. Run. Alrighty, we can stop right here. Like you said, you see the frequency is 9.8. The high is 2.6, which is very close to 2.5, and the low is 16.3 millivoltage, which is very close to 0. And now I'm gonna do the second trial for the square wave. So like now you said it is running, but now when I hit the button, everything gonna get set up again. It's gonna re-ask you all of the question. So maximum voltage now gonna be 3. Frequency, I'll choose 5. 0 for square wave. And let's see what we have. Stuff like you said, we have frequency is very close to 5 Hz. For the high, we have the maximum is 3.1. The low is very close to 0. And that is all for the square wave. And now you're gonna do the demo for the triangle wave and the sine wave.
Okay,
Here we go.
so now we do the triangle wave first. So as you can see, it's still generating the square wave because it doesn't show anything. So if I press the button, and it will re-ask me the voltage. So I will do 3 for my, or I can do like 4 for my voltage. And then for frequency, you can do 15 Hz for frequency, and we'll do the triangle wave with 1. So right now it will generate that, and you can see on the oscilloscope, click run, it generated a triangle thing. So you can see that the frequency is very close to 15 Hz, which I inputted in. And you can also see like the peak of the triangle is at 4 voltage that I input in the voltage.
And also the lowest point is 0.
Yeah. Okay.
You wanna try another frequency?
The frequency, okay. So I will try another frequency with the triangle wave by pressing the button, and will asking me again. So I can do like 3.5 voltage, and then I will do like 8 Hz for the frequency, and then triangle wave with 1, and generating. So let's look at the oscilloscope now. Okay, as you can see, the frequency is like 8, close to 8, and then we can see the peak of the triangle is around 3.5 as we expected, and the low is like near to 0. And then now we will move on to the one thing I want to mention is I would sleep up 0003 inside my sine wave and the triangle wave, because I do the experiment to start timing the elapsed time between the raw value assignment, and I saw that the average time elapsed time for this instruction is about 0.0007 second, and for our step it's gonna be this one. So the sleep time actually just I use 0.001 minus the average time. So I let it sleep this much so I can complete generate the form. So okay, now I will press the button. I will asking you again. I will do with 2.5 volt now, frequency of 14, and then the sine wave of 2. So it's generating, and then I will click run. For oscilloscope, you can see that. And then for this one, let me stop it. So for frequency, we can see that's 14 Hz, around 14 Hz as we expected. And then because for the raw value of the DAC, we cannot like make it assign to below 0, so I have to put something in to shift it up. So if you can see here, 0, and then we have a high of 4.
You want to mention about like you adjust it so like it doesn't get over 5?
Yeah, okay.
The function.
Okay, so the function sine wave. So I have add 1 right here, and then 0.5 of the sine. So it will shift the whole DAC sine wave up, so it will not exceed that, and then max volume, and then 0.5 to like have scale down the sine wave so it will not like go to 1.
By the way, if our input voltage and the frequency input is make the voltage higher than 5, it's gonna send error. Because our limitation is 5. And this equation we inspire by the equation given in the lab manual.
Yes, and we just add the frequency in to make sure we can draw the correct sine wave with correct frequency.
Correct.
And then also we'll demo later the frequency that make the voltage that make the thing not working.
Okay.
Okay, so let's try. Yeah, it's still generating. So we're at 4. And then
you want to move on to the next one?
Yeah. So if you can see right here, from here to here like 1, from here to here 1, so go down here like 0.5. So it should be corresponding to our 215 voltage, and the frequency like 14 Hz as we expect. Now let me press the button. Okay, let's try 2. So frequency will be 10, and then sine wave again. So we're generating. Click run. Okay, the frequency is like around 10 as we expected, and the voltage, we can see that there's 3 over here and 1 at low, so like the delta, like the change in the voltage should be like 2 as we expected. And it's like off 1 unit because we shifted up to avoid the negative value for the dead.
Okay.
And then I will try something more. I will press the button. I will try 5 voltage, and then the frequency of 10, and the sine wave. It will tell me
the error. Because the value is greater than 4095, which is above 12-bit, which is what we have on our deck. Therefore, there's a limitation on that, which we have to be aware when we input the frequency and the voltage value when we want to run the sine wave. And that's all?
That's all on my end.
I think that's all too. Okay, that is all for our lab demo. And thank you very much for spending time listening to us. Bye-bye.